Hello, everybody. So, today we are going to discuss atoms, molecules, and radicals, the first part of this new chapter. So, we know that every substance of this universe, these are actually made by the atoms. Simply the matter that is actually made by the atoms. So atom is an English word, but it actually comes from a Greek word atomos. And the meaning of the atomos is indivisible. That means that cannot be divided further. It is not possible to see the single atom with your naked eye. So you have to use the special kind of microscope to to see the atoms of any individual element or a compound. So the atoms, these are the smallest particle of an element that exhibit all the properties of that particular element. For example, if you think about the atom of iron, and that particular atom of iron, it shows all the properties of the atom of iron, but it differ from the atom of zinc because zinc is a different element. So for every individual element, it made up by atom, and that particular atom, it exhibits all the particular properties of that particular element. And atoms, it may exist independently or it may not exist independently. You will learn in this chapter only that the atoms of the metals, it has the individual existence, but the atoms of non-metals, it cannot exist independently. They combine with the other atoms of the same element or the different element for their existence. So atoms actually join with each other to form the molecules. So the first point is that atoms is the smallest particle of an element that exhibit all the properties of that particular atom, but the atom of one particular element is different. It shows the different properties from the atom of any other element. Next is that atom is the basic unit which actually takes part in the chemical reaction. An atom exhibit, it may has the individual independent existence or it may not have the individual existence. Okay. Now you see, atom is the smallest particle of an element that exhibit all the properties of that element. It may or may not exist independently. As I discussed that the atoms of the metal, it has the individual existence. It can exist independently. But the atoms of the non-metal, it cannot exist independently. Next part, it takes the part in every chemical reaction. When a chemical reaction takes place between two or more substances, the atoms, the molecules which are made by the atoms, that simply break down, and they combine in a different way with the other molecules, other atoms, to make a completely new substance. So atoms, it actually takes part in chemical reaction. As I discussed with the example of iron and zinc, atoms of the same element are identical. Atom of sodium, they are identical, but they differ from the atoms of other element. An atom of sodium is different with the atom of iron. Next point is that atoms can neither be created nor be destroyed. So these are the actually points proposed by the English scientist John Dalton. In the year of 1808, he proposed the atomic theory, which is known as John Dalton's atomic theory. And it shows a light, it shows the path it is the beginning of the modern science. But nowadays, when the science is more advanced, it is proved that some or most of the conception of the John Dalton is actually not valid in nowadays. But it shows the light to track the actual path, and by following this path the modern science develops. So here these points, these are the John Dalton's atomic theory. Atoms can neither be created nor be destroyed. Now it is actually established in the world, it is proved that atoms can be created and atom can be destroyed, and it is not indivisible. You know, you will learn later that the property of the element radioactivity, that you will see that atom can be created or the atom can be destroyed. When you will learn about the radioactivity in higher class, you will learn that atoms can be created and atom can be destroyed. Now you see the point that atoms are indivisible. What I say earlier, that atoms are indivisible, but modern science proves that every single atom, it contains the three subatomic particles, namely the electron, the proton and the neutron. Now the electron, this is the kind of subatomic particle which has a negligible mass and it carries the negative charge, unit negative charge. Proton, it is a positively charged subatomic particle and it has some mass, but it is not like that the negligible mass of electron, but proton has a mass. And another subatomic particle is a neutron, which is electrically neutral, and the mass of a neutron is almost equal to the mass of a proton. Now you see this table, these are the three subatomic particles, electron, proton and neutron. Electron can be represented by the symbol E0 minus 1 or simply E minus 1. This is the symbolically representation of an element of the subatomic particle of electron. The charge carried by an electron is negative charge and it has the charge 1.602 into 10 to the power minus 19 C. C stands for the unit of charge, Coulomb, according to the name of the scientist Charles Augustus the Coulomb. So electron carries the charge, one negative charge 1.602 into 10 to the power minus 19, and the mass, it is almost negligible mass. You see the mass of an electron calculated is 9.1 into 10 to the power minus 28 gram. Minus 10 to the power minus 28 means, in the consider a fraction whose numerator is 1 and in the denominator after 1 28 zeros are there. So you can imagine that how negligible mass of an electron. So we are actually considering the mass of an electron is almost negligible. Proton, it is represented by the symbol small p, 1 plus 1 or simply p plus 1. The charge carries is equal to that of the electron, but remember the charge of an electron is negative and the charge of a proton is positive, but the magnitude of the charge is same. It is also 1.602 into 10 to the power minus 19 Coulomb, the charge of a proton, but it should be considered that the positive charge, and the mass is much more as compared with the mass of an electron, 1.6 into 10 to the power minus 24 gram. Next subatomic particle is neutron, which is represented by the symbol n, small n, 10, n10 or simply n0. The charge 0, that means it has no charge, and the mass of a neutron is equal to the mass of a proton, 1.6 into 10 to the power minus 24 gram. Now come to the next part of this chapter, that is the molecule. Molecule, this is the smallest particle of an element or a compound. That means you can consider that molecule is the basic unit of a substance. It may be an element or it may be a compound, but the difference is that the molecule of any substance, it has the individual existence. When the atoms of the same element or the different element combine with each other, they form the molecule of that substance. Now you see molecule, smallest particle of an element or compound which has the independent existence. Now we are going to consider the molecules of an element. When two or more than two, the same element, atoms of the same element, they combine with each other, they form the atoms of an element. For example, you see hydrogen, H2. It means the two atoms of hydrogen combine with each other to form one molecule of hydrogen. You see N2. It means the two atoms of nitrogen, they combine with each other and form the one molecule of nitrogen. S8, S stands for the symbol of sulfur, 8. 8 means 8 atoms of sulfur, they combine with each other to form the one molecule of sulfur. Now this 2 or 8, this is actually terms as the atomicity. What is the meaning of atomicity? The number of atoms of an element that join together to form a molecule of that element. That means if you consider that in case of hydrogen, the two atoms of hydrogen, they combine to form one molecule of hydrogen. So you can say the atomicity of hydrogen is 2, or you can say hydrogen is an example of diatomic molecule. Say the atoms of any metal. I told you earlier that the atom of a metal, it has the independent existence. If you consider the atom of sodium, it represents only its symbol Na. So Na, it represents the symbol of sodium. But how many atoms are there? Only one. So sodium, it is an example of monoatomic element. Fe, this is the symbol of iron. It has only one atom. So this one atom, it forms the molecule. That means its symbol represent that Na or Fe, it represent the atom as well as the molecule. So these are the examples of monoatomic element, because their atomicity is only one. One atom form the element. But if you consider that S8, that means 8 atoms of sulfur, they combine with each other. So it is octaatomic. If you consider the molecule of ozone, O3, 3 atoms of oxygen, they combine with each other to form the one molecule of ozone. So ozone is an example of triatomic. So monoatomic, diatomic, triatomic, tetraatomic. If the number of atoms which forms the molecule of an element is more than 2, we can say it is polyatomic. So sulfur, it is an example of a polyatomic, and ozone, it is also the example of polyatomic, or you can especially you can represent it's a triatomic, which is also a polyatomic. Hydrogen, nitrogen, these are the diatomic. Sodium, iron, these are the examples of monoatomic element. So today up to this much. Thank you.